We'll try. I got a mechanical pencil.
I lost mine.
We're allowed that too.
Yes, both of these. Not that we're going to lose that.
Good enough.
That's the use this.
Thank you, Mr. Ryan. Appreciate it.
Okay, like one of these.
Yeah.
Alter
Oh, yes.
Such a relief.
It's better than this. How hard can it be?
It's just, see, yeah, I know. No, I know. I know it's not.
Didn't want to.
And then you try to get it.
Just don't go guys on this. Go into the test with your mechanical pencil and not have any extra lead.
The endless cycle of trading.
No, like I don't know what it's close to the test later. So I just walked up and said, hey, can I have your pencil?
Yeah, like I would try. I always do.
They didn't get it.
Well, I mean, if it works, it works.
My calculator died last year.
Yeah, that's where I came from. Right?
Yeah, luckily, I have to make sure.
Okay, so I think what we need to do today is we need to finish up talking about the binomial theorem and the applications of it. I think we just have a couple problems where we find the missing coefficient, and then we also have to go backwards from the series into the closed form. And then we'll spend the rest of the time today talking about what's on the examination, and then that way if you guys have some questions for me, I can answer those. Okay? And just as a reminder, assignment number 10, that's going to be due next Monday, and the exam is on Wednesday. Okay, so any questions before we get started, guys?
I thought the exam is Monday because tomorrow is election.
What's that?
Tomorrow is election.
Unfortunately, election day is not a federal holiday, so we can stay open for that as much as we want. It's great. So, other questions, guys? Okay. So last time we went through and we went backwards and we talked about what happens if we want the missing coefficient. Okay, and we did it for a fairly easy problem. Let's take a look at a couple more that might not be as easy. Okay, so I want to try to find the missing coefficient of the term a6b6 in the expanded binomial 3a squared minus 4b to the 9th. Okay, so I think what we might want to do is we might want to identify a, b, and k in this problem. Okay. So if I was to ask you guys what a is, and by the way, we're using, when we say a, b, and k, we're talking about in the expanded form of the binomial theorem. So in this problem, what's a for us? 3a squared. It's the first term. Thanks. Okay. So we're going to say that a is represented by 3a squared. Okay. B would be represented by what, guys? Negative 4b. Okay. Don't forget your sign there. Okay. And then finally, if I was to ask you what k is, what is k in this example?
9.
It would be 6. What is 9, guys? 9 is n. Okay. But if we want k, we're looking for what's affixed to the variable b in this case, since b is minus 4b. So k in this case is going to be 6. Okay? Does that make sense to everybody, guys? Any questions about that? And clearly in this problem, n is none. I forgot to mention what n is, but n is probably the easiest thing to figure out. In fact, a, b, and n are all pretty easy. Okay? All right, easy enough, right, guys? Now we stick it back into the binomial formula. Okay, so we go back, and if you guys remember, okay, it's at the top of the page on the other side. This is your binomial formula right here, so we're going to utilize this. So we're going to say a plus b to the n is equal to n combination k, so that's going to be 9 combination 6. A, in this case, which is 3a squared, raised to the n minus k, or 9 minus 6. And then we're going to multiply that by b, which we said was minus 4b, this time to the kth power 6. Okay. And again, all we're doing, guys, is we are substituting it directly into this part of the binomial theorem, except without the series, right? Because we just want that singular term that's in the binomial. Okay? Is that easy enough, guys? Any questions about that? The rest of the problem, we punch it in our calculator and we're done with it. Okay? So let's just go ahead and do that. Okay? Did anyone figure out what 9 combination 6 is by chance?
84.
In stereo. Thank you, guys. All right. So that's 84. And then this just becomes 3a squared to the third. So this is going to become 3 to the third, which is 27. A squared to the third, which is a to the sixth. And that's good news because we need an a to the sixth factor. And then we also need to figure out what 4 to the sixth power is. Well, negative 4, but it doesn't really matter since it's an even power. So did anyone figure out 4 to the sixth? 4096. Does that sound good, everybody? Okay. Thank you, gentlemen. 4096. And then b to the sixth is b to the sixth. Okay? So now all we have to do is just use our calculators, multiply 84, 27, and 4096. We get some horrific number. Okay, so was anyone able to figure out what the coefficient is for us?
928, 9728.
928, 9728. Okay. Is that Donnie's phone number? Did you get that on the bathroom wall? 928. Yeah, it sounds like it's about right. Oh, we forgot the 453 in front of it. Or do you guess it's 976? Those were the chat lines, right? So I've heard.
1-900 number.
1-900, that's right.
It's an easy money right about it.
Man, we're done. I think you need a hug, buddy. All right. Does that make sense, guys? All we're doing is we're just identifying these 4 characteristics and just throwing it back into the binomial formula. It's very easy, okay? Not meant to be different. Okay? It's a little bit sneaky sometimes, though, when the coefficient or the exponent power isn't necessarily, I guess, easy for us, okay? Especially with the k. In this one, k was fairly easy to identify, but if we look at the last one, it's not as easy. Okay, so I'm guessing everybody in this problem could figure out what a is, what b is, and what n is. But k in this problem might be a little more difficult than what you suspect. Okay, let's do the easy stuff first. Okay, would anyone be offended if I said a was 5x squared, if b was negative y squared, and n was 5? Okay, that should be fairly easy for everybody. But I bet you I know what everyone's going to say. Well, I'll bet you I know what a lot of you guys would say what's going to k be. And a lot of you guys are going to say that k is equal to 4 because that's the variable, or that's the exponent of x to y. It is not 4. And that's kind of contradictory to what we've been thinking before, because we just look at the exponent that's affixed to the second factor, and we just throw it in there. So it's not. How come it's not 4? Well, first of all, what do you guys think it is, Steve?
Well, is it because the first factor is higher than the second one?
Okay, well, it doesn't necessarily matter which one's higher or lower than that. That's okay. But, John?
Is k 2?
K is going to be 2 in this instance because we're looking for y to the 4th, and we need to make sure that whenever we apply the exponent to y squared, we get to y to the 4th. So basically we're saying y squared to what power is equal to y to the 4th. Or in other words, y squared to the k equals y to the 4th. All right? Now the only reason we didn't do that before was because the exponent was to the first power. But since the exponent's to the second power, we have to ensure that we get to the right one there. And John, you're absolutely right. It's actually going to be wind up being that k is equal to 2. Okay? Does that make sense to everybody, guys? It's because this second binomial term is squared. Okay? What if I was looking for, let's say, y to the 8th? Okay? What would k be if y was to the 8th power? 4. Okay? Because you would have to square y to the 4th to be able to get to y to the 8th. Okay?
Oh, okay.
Does that make sense, guys? All we're doing is we're just looking at this, and we're saying, what do we have to raise it to get to this exponent right here? Okay? So it's a little bit different than some of the other ones. Okay?
So if it was 8y squared, or multiply 2 times 4.
If it was y to the 8th, then k would have to be 4. If it was y to the 10th, k would have to be 5.
5, 12
okay?
will be 6, okay.
Right. Does that make sense to everybody, guys? Okay. once you have that, the rest of the problem is easy. Okay, so just be careful when you start having these squared terms inside the binomial. Okay, so we set it up. We have 5 combination 2. Okay, so n combination k. It's going to be a to the n minus k, so 5x squared to the 5 minus 2. And then negative y squared, and since we said k was 2, that's going to be to the 2nd power. And by the way, guys, if it doesn't expand and you don't get x6, y4, that's a clue that you've picked k incorrectly. I mean, figuratively, if you're sitting on there on the exam and you have no idea, I mean, you know I'm not going to give you guys n any bigger than like 9 or 10, so you can literally just sit there and do it 9 or 10 times. I mean, it might take you guys 5 or 10 minutes, but at least you'll get the right answer. Okay, so that might be my suggestion. If you have no idea how to do it, just beat it up, brute force it. Okay. All right, 5 combination 2, that's 10. 5 to the 3rd, 125. X squared to the 3rd, x to the 6th, so at least we know we're on the right track. And then negative y squared square, that's going to be a positive y to the 4th. So it looks like to me we get 1,250 as the coefficient, x6, y4. And I want you guys to notice that we did indeed end up with the correct exponential powers, x6, y4. Okay? By the way, I forgot to circle the actual answer for the last one. Okay? Because we're only looking for the coefficient. We don't care about the other stuff. Okay? Although I wouldn't be so cruel as to mark you guys wrong if you didn't circle just the coefficient. Okay. Oh, sorry guys. I didn't realize the computer was in some of you guys' way. Apologies, apologies. Okay. All right. Does that make sense, guys? Any questions about this? Okay. On your guys' exam on Wednesday, you guys will see something like this. Go home, practice a few of them. Look in the textbook if you need help. If you need some more problems, email me. I can pick some out of the text that's posted online for you guys. Okay. Another type of problem that we haven't looked at yet was what happens if I give you the series and I want you to go to the closed form of the binomial. Okay. So these aren't too difficult either. Okay. So I give you guys this series. Okay. K equals 0 to n combination k, 5 to the n minus k, and then 2 to the k. Remember what our binomial theorem says. If you can identify what A is and B is, you can just stick it back in and get a closed form. Okay? So if I was to ask you guys in this problem, what are A and B? Okay? Guys, what are A and B in this problem? 5 and 2, right guys? We don't need the exponents because we're just looking for A and B. So A is 5, B is 2. So really, wouldn't this series, because it fits the binomial series, wouldn't that just become 5 plus 2 to the nth power? In fact, it doesn't even matter what k is, okay? So some of you guys might have seen this binomial series in differential equations if your teacher was really difficult and gave you guys very, very difficult problems, okay? There's something called a binomial series that does arise on occasion in differential equations. You might have even seen it in Calc 2. Okay? But really, the k doesn't matter if it's in this form. So this just works out to be 7 to the n, which is much, much easier to evaluate than just going through and trying to figure out the sum of all those terms.
Why did you add them again?
Oh, because remember the binomial theorem? Let's go back to what the binomial theorem says. The binomial theorem says that if you have something in this form, okay, right here, which we do, it's equal to A plus B to the n.
Gotcha.
So all we're doing is we're just taking this and we're turning it into that. That's all.
considered closed form, right? The
Correct.
side, that's
Yeah.
actual closed form.
Yeah, that's the much easier form to work with. Because now all you have to do is just plug in for n, right? That's a closed form or an explicit form where you just plug right in, okay? So let's say for some reason n was something like 55 and k was 33. You guys would have to do this problem literally 55 times and evaluate and add it. Or if you knew the closed form, you just stick 55 back in for n. Okay, that's all you would have to do with it. Okay, it's much easier to work with a closed form than doing that series. Okay, take a look at the second one, which doesn't look like it fits the binomial theorem, but it actually does. Okay? By the way, 7 to the n is the answer. So I did circle. All right. Now, a lot of you guys are looking at that, And you're like, okay, well, I can easily identify one of the two, either A or B, but I don't necessarily know the other one. So let's think about this, guys. In this problem, what do we have that's pretty apparent, A or B? We have B. B is what, guys?
15.
We can't get that one. Well, we could, but that would be perfect. So does that mean we can't do this problem, or can we identify done?
Multiply by 1.
Yeah, you can multiply by 1, right? Guys, could we say that this binomial series is exactly the same if I were to multiply by 1 to the n minus k, right? Guys, isn't 1 to the n minus k 1, no matter what the values of n are, right? Because 1 to any power is a multiplicative identity. Donnie, you're absolutely right. That a in this instance just happens to be 1 because it's an identity. Does that make sense to everybody, guys? If you're either missing A or B, just make it 1, okay? In fact, you could do the exact same thing if you guys didn't have either the A or the B in this. You could make them both into 1s if you really wanted to, okay? Now we just plug it back into the formula. We know that it's going to be 1 plus 15 to the n, which is going to be 16 to the nth power. Okay? Which I know you guys don't think of as easier to work with, but it's much easier to work with than that binomial series that exists there. Okay? Any questions, guys? Not meant to be difficult. Just making it flip into a different form.
Would we ever need to go the other way and turn 16n into the series?
I could think of some scenarios that you would, but they're so, I just can't see it being used too often.
Okay, it's not really practical.
It's not
So
very
you wouldn't have to
practical.
worry about something.
I wouldn't worry about it, quite honestly. Okay. The other way I could, like this way I could see being useful, but the other way I can't really see being too useful. Okay. Unless like you have a really obscure problem that just happens to fit the binomial series. Okay. All right. Other questions, guys? Okay. For the third one, okay. We have another sort of binomial series that's going on here. Okay. It's not quite though in the right form. Okay. There's a couple things that are off. First of which, you guys will notice that there's 3 factors in here, okay, but I'm guessing a lot of you guys know what to do to take care of that. But there's also one other inconsistency here. So somebody tell me something that we could do to make this fit the binomial form.
Negative 3k plus 1 and take the negative out.
No, can't do that, okay? Are you trying to add those together?
Yeah, or else negative, what you can do, 3k minus 1?
Not quite. You're on the right track. I think you know you can do something with that negative 1 and 3 to the k.
Yeah, that's like negative 3. That's
negative 3 to the k?
Yeah, they both have the same power,
Oh,
so
yeah.
you just combine it and make it negative 3 to the k.
Okay, yeah.
Okay? So, I like that idea. Nice, Sean. Guys, it has the same exponent. Because it has the same exponent, you can go ahead and simplify it. So it would be minus 3 to the kth power. That's completely legal. That's actually going backwards from the power rule. Okay? Now, what's something else that's incorrect about this that we might need to fix? Donnie?
K minus n.
Yeah, it needs to be what, sir?
Can you just, since it's
n minus k.
4k minus 1 to n.
Okay, so, in other words, Donnie, you might have said it incorrectly, but is this what you meant? Like pull out a negative 1 and make it n minus k?
No, I meant like 2 whole different values.
Just shut up and say yes or no. Okay, that's what you should do, okay? Guys, I want you to notice, and I'm glad you did notice the right thing, okay, which was good, okay? I think you were just thinking like maybe algebraically of something different. This is the most, I think, efficient way to get there, okay? But it's good that you spotted that. Nice. Guys, notice that the exponents were flipped around in the order. If the exponents are flipped, you factor out a negative 1. Okay, does that make sense to everybody, guys? That's easy. So now we can easily identify what A and B are, right, guys? All right. A in this case is going to be what, guys?
1/4.
1/4 or 4 to the minus 1. Good. So this is going to be 4 to the minus 1, which is equal to 1/4. Okay. And then clearly, guys, B is what? Negative 3. Nice. All right. So that's easy. And now it just fits the binomial form very nicely. Okay? So for us, we're just going to do A plus B to the n. So that's going to be 1/4 plus negative 3 all to the nth power. So A plus B, and that's going to turn into what, guys? Negative 11/4, I believe, to the n? Sure, why not? Make sure you guys put it in parentheses. Without the parentheses, it is not correct. Okay? In fact, I probably should write it out here. Not that it matters too much. Okay? And of course, guys, use your calculator when you're doing the addition of fractions. I know it seems trivial, but again, you don't want to lose a point or two on the exam because you didn't add the fractions correctly. Okay? Does that make sense to everybody, guys? Much, much easier to work with negative 11/4 as opposed to this horrific series. Okay? All right, why don't you guys try the very last one there? See what you guys can do with that. Okay? And then we'll go ahead and go through the answer together. And then we'll go ahead and talk about what's going to be on the exam for next class. Yes, sir?
Does this look okay?
No.
Does it?
What happened to your 3?
Oh, three.
Yeah. There you go. Now it looks
No.
good. Okay.
Yeah, you can't just make that disappear. Sorry.
Go.
Yep.
Looks good.
Nice.
I'll give you guys another 30 seconds to finish up. We'll go through the answer together. You don't have to write this down, by the way. Don't look at the board. This is just for fun. Okay. Okay, so for the problem that we were just working on before, okay, can somebody tell me what they did to start this problem to be able to put it into the correct form?
Yeah.
Okay.
So
go ahead.
negative 1 n minus k,
Okay.
then 2 to the power negative 3 n minus k
Okay.
multiplied by 8k.
Okay. So basically, you just factored out the negative 3 to start that.
Yeah.
Okay, that looks good to me. Okay. Unfortunately, we can't yet quite identify what A and B are for this problem. So what's the next thing you guys might have done to be able to get a little bit closer to the closed form?
So 1 over 2 to the power 3, basically.
Okay, so you could write this as 1 over 2 cubed, or because these both have exponents of n minus k, you could actually just multiply it together and rewrite this as minus 2 to the minus 3 to the n minus k. Okay? Or you could do it your way. Okay, that's fine with me. Okay? I'm just lazier than you. Guys, if they both have the same exponent, it's completely legal to multiply those together. Okay? And you just carry that negative 3 over. Does that make sense to everybody, guys? Any questions about that? Okay. How many of you guys did this first? Like wrote it as 1/8 quantity to the n minus k, and then you had your minus 1 to the n minus k, and then you multiplied it there. How many of you guys did that? Okay, that's fine. Okay. How many of you guys just skipped right down here to get minus 2 to minus 3?
I did both those to verify.
Okay, that's fine. That'll work. Nice. Okay, I don't care which way you guys do it. Okay. So clearly in this example now, A is equal to negative 2 to the minus 3. Okay. And then B is going to be equal to 8 for this. Oh yeah, sure. If you want to write A as negative 1/8, that's fine too. I don't care. Because eventually you could go ahead and compute that and just write that as negative 1/8. Sure. Okay. So now clearly we have A, we have B, so that's negative 1/8 plus 8. And I think that's going to be 64/8 minus 1, so 63/8 to the nth power, maybe? Quantity to the nth. Okay. And believe it or not, guys, that is much easier to work with than this horrific series that we started up here, especially if n becomes very large. Okay. All right. Guys, any questions I can answer for you guys pertaining to if you have the series, how do you go backwards to a closed form? Okay, pretty neat that we can do this. Much more efficient than some of the other things. Okay. All right. Just one thing, and this is pretty trivial, but I thought it was kind of fun. We were looking at the I guess the binomial theorem. We looked at Pascal's triangle the other day, right, guys? And there was some wizardry going on. I think Chrissy said there was some sort of wizardry going on there. I actually found like a little bit more wizardry that was kind of neat with this. So just in case anybody cares about this, Donnie, can I borrow you? Actually, I can't because you're not even tall enough to reach the high numbers. Oh, maybe later, sexy.
He is.
All right. I'll do it myself because you're incapable of walking up the board. If I were to circle just the odd numbers in this, okay, and this seems like a pretty trivial sort of thing to do. Okay? So, what's that?
I said, by the way, I could reach the top.
Yeah, if you stood on a step stool. Yeah, sure. All right. But I'll just go ahead and circle the odd numbers.
Good triangle.
What's that?
They're gonna be big thin triangles.
Oh, really? Oh, Mr. Smarty Pants.
Thin triangle,
What's that?
right? This one.
What's that? I'll get it when I go back. I'll get it when. Which one did I miss, sir?
One.
One.
Oh, yeah.
Yeah, it's pretty neat that if you guys look at what's circled there, and unfortunately we can't see any more of this, but you guys can easily see that some things that, if you were to carve out the outline of this, you guys get, looks like some triangles in there, don't we? Huh. Yeah. Isn't that neat that sometimes we get self-similar shapes that exist within shapes? Or in other words, what's that called that starts with an F? Rhymes with mactal. It's a fractal. It's actually a field called fractal geometry. If only there was somewhere you guys could go to learn a little bit more about fractal geometry. Hey, guess what? This Thursday, check this out. Thursday, which is November the 10th, from 4 p.m. to 5 p.m. in Aberdeen 224, I'm going to be giving a little colloquium about fractal geometry. Then you guys are all invited. There's going to be some food there. So if you want to come, just email me. I'll just go through some fractal stuff. No tests or anything like that. I might even throw you guys a few extra points on your examination if you guys make your way there. Okay, not obligated, but just telling you guys that it's a pretty neat sort of thing that
Is
I'm doing.
Outback
Enough food to skip dinner, or should I still prepare?
What's that? What's that?
You said it.
Oh, pizza, cookies,
So, yeah.
cooking, yeah, all kinds of good
Oh, that's
stuff.
my favorite food.
Yeah,
no
absolutely.
steak?
What's that?
No steak?
Dude, you don't want meat in your mouth, do you?
I love
You do?
it.
Okay, whatever. So, yeah, but you guys are welcome to come. All you have to do is just email me and let me know you're coming so that way I can order the correct amount of food. Okay, so it sounds like fun. If you're not free, I completely understand. Okay, but you guys are welcome.
Any booze?
What's that?
Any booze?
There is no booze, unfortunately. This is a
Oh.
dry campus. I know. At least you guys won't have any. I'll have some. Okay. So, and I'll show you guys all kinds of really neat things just like that. You don't have to have any knowledge of mathematics, which is evident because you're in my class. Nobody learns anything about math in my classes, so that's cool. All right. Speaking of learning, what's that?
Why are you doing this?
Just because I like doing it. Okay. Actually, the math club and Phi Theta Kappa are joining together to do some stuff with this. So.
Right after this ends, the meeting, the math club meeting's still going. So.
Yeah. Okay. Yeah. And
So it's
by the way, if anyone's interested in joining the math club, we do have the president on hand, Angeliki. I'm sorry, I didn't mean to put you on the spot, but Angeliki's the president of the math club. So if you guys are interested in doing some of the events with the math club, I'm sure you guys are always looking for active members to do some fun stuff with. So ask her about it. Sorry, I didn't mean to embarrass you. I know. Okay. So anyway, we have an exam coming up, right, guys? Enough of this trivial stuff. So let's talk about what's going to be on the exam. By the way, was that wizardry? Is that like hocus pocus good stuff? Yeah. If I would have kept going, you would have seen more triangles, but like I said, I got lazy at the end. So. But regardless, guys, let's talk about what's going to be. Oh, my bad. You gotta tell me before I start erasing.
Very trivial.
So Thursday from 4p to 5p.
Oh, no. You can, I'm just.
Oh, that you don't care about? All right, I'll go over here. How's that sound? Since nobody cares about this.
No, that stuff doesn't matter.
Oh, that doesn't matter, you know? No, I know. You know, your passion for mathematics, I don't give a shit about that. That's okay, I understand. Okay, so, the third exam, basically, guys, that's going to be assignments 8 through 10. Okay. So essentially the topics that I would go back and study, certainly go back through and look at all the set stuff. I'll go through a little more detail, but just to recall, okay, sets and everybody's favorite proof of sets. Okay. All the counting methods. Okay. And then we have permutations and combinations. And then finally, we have binomial theorem. Okay, so if I was to break it up into the few topics that you guys should be aware of as to what's on the examination, those would be the 4 topics that I would go forth and study. Okay. Much like the last examination, I'm going to do it to where the first 10 problems are just really short answer questions, okay, like 2 points apiece, like either you know it or you don't sort of questions, bless you, all right? Make sure you guys study those. A lot of you guys lost, like, I mean, there are so many guys that lost like 15, 16 points on those, and you only lost like 10 points on the rest of the test because you didn't study like the easy stuff. So make sure you guys study the easy stuff, okay?
Like, is it a subset or element?
Oh yeah, I'm going to go through it. So, but yeah, like some of the things that are like the easier problems, like for instance, like I'll just say part 1, if you would. Okay. Like for example, if I give you a set S is equal to something like 1, 2, 3, 4, 5. Okay, and I give you guys a set T is equal to like 3, 6, 7. Okay, and let's say we have a universe, that might be helpful too, which I forgot to do on that assignment. I revised it, so let's say the universe was 1, 2, 3, 4, 5, 6, 7 for some reason. You guys probably know what to expect. I might ask you guys what's S minus T. Okay, so I might ask you guys something like, what is S minus T? What is something like S intersect T complement, okay, I might ask you guys something like, I don't know, T complement union S minus U.
This would all be 1 2-point or a different problem?
No, they're all different 2-point problems. Okay, so that would be 6 points, since there's 3 different problems. Okay, right?
Could we use our rule sheet
Oh, yeah, you, absolutely, the ones with the,
with the set?
oh, yeah, absolutely, sure. Okay. I'll probably give you guys like some of those problems where is it a set, or is it an element, or subset? Go ahead, sir.
You put up 2 little lines on the U to make sure you're not seeing.
Oh, that's okay, I think everybody knows, because there's nothing, oh, I see what you mean, okay, it is possible, okay. Gotcha, okay, there we go.
What do you do on the S intersect T complement? It's like 1, 2, 4, 5. Intersect is the 3,
Well,
right?
intersect between S and T would be what's similar, so
3.
the only intersect would be 3.
And
But then you would take the complement of that, so that would be 1, 2, 4, 5, 6, 7.
7, okay.
Okay? So for 2 points, if you could do that, there you go. Okay? Does that make sense, guys? Most of you guys did really well with this, or whoever you guys copied it from did really well with it, whichever it was. Okay? Then we also had some problems where I asked you if it was a set, or if it was a subset, or I guess an element of. So remember we had like these problems like squiggly, squiggly 3, and then blank, squiggly, squiggly 3, 4, 5. Okay. And I might ask you to fill in, like, is it a subset, or is it an element, or neither? Okay. So I'll probably have about like 2 or 3 of those on there, just to kind of make sure you guys understand the difference between subset and element, or if it's neither of those.
So, but what if it, in this case it is both a subset and an element, right?
No, it can't be both a subset and an element. That's not
So
possible.
this is an element, right?
It's a subset.
Subset,
Okay,
yeah.
so this would be a subset, okay? The only time it's an element if it looks exactly like what's inside the outermost parentheses, okay? So it would have to be an element, it would have to be this, of the exact same thing, okay? That would be an element if it was just a single squiggly, because it looks exactly like what's inside the parentheses, or inside the squigglies. Does that make sense? If it doesn't look exactly like what's in there, in other words, it has 2 levels, then it's not going to be a subset, it's not going to be an element. Because an element means it's exactly what's inside.
I got a question, the first one. On the left hand side, right?
Yeah.
So that set's element is the squiggly 3, right?
This is set of set 3.
Yeah, so the element is set 3 on the left hand side, right?
The outermost element, the outermost set's element is set 3, is what it's saying.
Okay, so this
Uh-huh.
would be the element that matches up to that. That is an element, okay? Because this looks exactly like that. Exactly. No difference. It's a mirror image.
But then why is this not an element? Because you have 2 squigglies, right?
Right.
Other stuff in the other,
It has to look exactly like the inside of the squiggly
and they
brackets.
both would need to be 3, 4, 5. Be an element.
Yeah, but they look alike.
But they don't look exactly alike.
Oh.
For it to be exactly the same thing, exactly. Like for instance, okay, if I had this, 5, blank, 3, 4, 5.
This is an
That
element.
is an element.
Not a
Because
subset.
this looks exactly like
Element,
that.
yeah.
That is an element, okay? Because it looks exactly like what's inside. However, if I had this, that's a 5.
It's a subset.
4, 5. That is a subset of that because it doesn't look exactly like what's inside, okay? Because there's no squigglies around it, okay?
Uh-huh.
So again, it has to look exactly like what's inside for it to be an element, okay?
Huh.
If it has one more level of parentheses, that means it's a subset.
And if it's a subset, it has elements of the set you're comparing to.
Correct. Right. It has to have the elements inside of that set, okay? So does that make sense?
Yes,
You
that's
still
it.
look, you still look like you're confused with it.
No, because what is happening is on the outermost, the left thing, because you had like between there are like 1, 2, 3, 4, 4 squiggly on the left hand side, right? The outermost. So there, on that set, that looks like that set's element is the squiggly 3, right?
Yes.
On the outermost.
Okay, so this would be, are you,
It's the set of
this is
that.
set of set
3, yeah.
Right,
And that one is basically what you're saying is that those elements of that set is squiggly 3, squiggly 4, squiggly
Correct.
5, right?
right,
So the elements are matching, right?
right, okay?
The elements
But
inside.
this is the set, not just the element.
Subset element.
Okay.
Got it.
So it's not the same thing because there's 2 parentheses there. Inside there are 1 parenthesis.
Parenthesis.
It doesn't look exactly the same
But you have to set another set of parentheses on that.
because that would make it a set.
Set,
not a
got it.
Yeah,
set.
subset is literally, it's literally a set that is inside of the other set.
Set
You're saying,
element,
is
yeah.
that set inside this set? And in
Yeah.
that case, when it's 2 squigglies, it is.
Yeah, got it.
Since there's the same level of squigglies on both sides,
Call it
it
squiggly.
has to either be a subset or neither.
That's correct. Okay, yeah, you have to have either the same number or 1 less. And
Gotcha.
otherwise it's nothing. Okay. All right, so like I said, I'll probably have about 3 of those on there, so you guys just go through. I mean, quite honestly, you got a 50-50 shot to either get it right or wrong. So, and if you study something, that increases your odds. Okay? All right. Trying to think what else. Oh, we had those problems where I asked you guys to draw a decision tree and then do some of the probabilities based on the decision tree. So, all right. So, you guys might have to draw a decision tree and then do 2 or 3 probabilities based on that decision tree.
And that would be a 2-pointer?
Well, each of the problems is worth 2 points, okay? So the decision tree would be 1 problem, okay?
Okay,
So,
and then each probability is,
Yeah.
okay, that's fine.
okay. It's almost like if I could get done explaining it, then maybe I could write the point down. But- So I would ask you guys to draw a decision tree, and then I might ask you guys to do 2 or 3 probabilities with the tree, okay? So essentially, guys, any answer that you write down is worth 2 points for part 1, okay? So, although if you just study everything, then it probably wouldn't matter too much, okay? So does that make sense, guys? Aside from giving you guys the problems, you know? Okay. So then the rest of the examination is going to be the more difficult problems where you have to apply all the stuff, all the fundamentals, okay? So with the set stuff, so this is part 2. Okay. With regard to the sets, I'm going to give you guys 2 problems. One to where you have to do the axiomatic proof. Okay, so sets. So I'm going to give you guys one with axiomatic, definition only. Okay. And just for example of the level of difficulty that I might ask you guys to be able to do, like I might ask you guys to do something like prove that A intersect B intersect C is equal to A intersect B intersect C. Okay. I might ask you guys to do something like A or A intersect B is equal to A. Okay. I'm not going to ask you guys to prove like something difficult like De Morgan's law, which is much more difficult to do. Okay. But something like that to where it's pretty fundamental, then that should be fairly easy for you guys. Well, not easy, but go back through the examples. Look at the solutions to the assignments, okay? So that might be a good place if you didn't do too well with this, okay? I always tell people that go back to the solutions first because that way you can figure out what you don't know, okay? That's probably the easiest thing you guys can do with that, okay? All right, and then I'll give you guys one to where you guys just use the set definitions, okay? So. I'm just trying to think of one that we did in class or for homework or something like that. But I think we had, and I don't know if this works, so don't go home and say, oh, I tried that, it didn't work. But like we had something like A minus B minus C equals to A minus B. Okay, so basically I'll pick one out that's on the sheet for you guys to use the axiomatic definitions to prove, and then I'll ask you guys to use the set definitions to prove those.
Are you going to provide us with those sheets like that? What is that sheet that why the properties of set, or we have to copy it?
Ryan, what did we say about that?
Yeah,
What did we say about the sheet?
it's more complicated.
Oh, yeah, we can use it.
Yeah, I said that you guys are allowed to use that.
No, but are you going to give us or?
No, you guys always provide your own stuff.
Okay.
Yeah, I'm not a mommy or daddy. You guys, I give you guys something once and.
So here we're supposed to prove it, and there were a couple examples where we were disproving something. Do we have to be concerned about disproving something too, or is it supposed to work out?
It should work out, but, you know, if it doesn't work out, it'd probably take you 2 minutes to figure out that it doesn't work out. So,
Okay.
I would just make sure you can do it both ways, okay?
Okay. I mean, if you can do one, I mean, if you can prove it, you can definitely disprove it.
If you can prove it, you actually can disprove it no matter what, because you'll
Right.
find a contradiction somewhere in there anyway, so. Unless you just did something wrong, then, okay. All right, other questions, guys? Okay, we started doing the counting method stuff, so make sure you guys can do the stuff with, if I give you guys like the words, how many real and fictitious words can you make out of it? So, like if I give you, like given the word, like, I don't know, no, that's not a word, it's 2 words. Good thing you're not an English major. Let's say happy or something like that. I might ask you guys like how many different 5-letter words can be made out of that. So, like number of 5-letter words. Okay. Or if I give you guys the word something like I know it's not the right spelling, but like froggy, all right? Make sure you guys can tell me the number of 5-letter words. Well, because if I do the right spelling, then unfortunately it's the same problem. Well, if you can think of a word that has unique letters in it off the top of your head while writing and talking.
France.
Algebra.
Algebra has 2 A's in it.
France, F-R-A-N-C.
Algebra.
F-R-A-N-C.
Loser.
All right. Bingo. All right. By the way, what's the difference between those 2
The
problems?
first one is combination, the second one
Combination
is
for the first one, permutation for the second
Second
one.
one,
Right,
yeah.
guys? What's the difference? One has repetition, the other one doesn't.
So the first one is like 5C5, and the next one is
Okay. I mean, there'll be
Factor.
more intricate than that, but you guys get the idea of what to expect with that. Okay. And then make sure, like, if I give you guys like some other scenarios, like if the first letter has to be a G or the first letter has to be a P, make sure you guys can do those types of problems. Okay. So all the stuff that was on assignment number 8, make sure you can do those. The jury problem, or like the number of people you can pick from, like a pool problem. So if I say, let's say there's like 8 men, 10 women, and let's say I have to pick 5, okay? All right, that type of problem. So, like for instance, I might ask you guys to be able to say, you know, how many ways can I pick the people? So number of ways to pick, okay? Number of teams with 3 men, 2 women. Probability of selecting at least 2 men. Okay, those types of problems. Okay. So all that stuff that's going to be the stuff on assignment number. I guess it was assignment 9 for you guys for that stuff.
the first one, like number of ways to pick. That should be like 18, choose 5, right?
Yeah, like number of ways to pick is the easiest problem. It just is what it is. Okay. And then the other ones you either have to multiply or use the addition rule or something like that. Okay. So just go back to assignment 9. Either look at the solutions or try to look at like some of the homework stuff that you guys have done with that. Okay. So any questions, guys, about those? Okay. I'm going to give you guys 2 problems where I ask you guys to prove a permutation fact and prove a combination fact. Okay, so So I'll ask you guys to prove, and I don't know if this is necessarily true or not, so don't go home and try it, but just to give you guys an idea, like 2 permutation n comma 1 minus permutation n comma 2 is equal to permutation n comma 1 or something like that. Like I said, don't go home and try that, but just look like for that level of difficulty with the problems, okay? Go back through the guided notes and try to find those. Trying to think of some of the ones for combinations that we did. Like, we had this one, n minus k minus 1, n minus k minus 3 was equal to something horrific, like over 2 plus 1. Okay. Yeah, something like that. Shame on you if you got that one wrong, by the way. So, or I might ask you guys to prove n, k, or like something like n minus 1 minus k plus n minus 1 k equals nk. So, but those level of difficulty, nothing that we haven't done in class. So, 2 of those, one's worth 10, one's worth 15. So. So basically, a core of the test is just algebra stuff.
Now for permutation, do you have to write it down like MAT or ATM? Do you want us to write those combinations down, or by the way?
Oh, no. If you want me to, I can put those in there. So it's up to you. But
nah, it's takes too long.
If I don't write it on the board, I don't ask you guys to do it. So, okay. All right. Other questions, guys? Okay. And then the last 3 problems are all in the binomial theorem stuff. So. These are easier ones, so they'll be worth 5 apiece. So for the binomial theorem, all right, make sure you guys can expand something like 2a plus 5b to the 4th power. Find coefficient of something like x squared y8 and x minus 3y squared to the 4th. I guess that would be the 5th. I want to make that right. And then, just like we did today, write the closed form of series k equals 0 to n combination k minus 1 to the n minus k. 2 to the 2k minus 2n. Okay, so, and each of those will be worth 5 points apiece. So, a lot of that stuff's on assignment number 10. So my suggestion would be, guys, try to work through assignment 10 as best as you guys can before the examination, just so that way you guys get some practice with that stuff. Okay. So basically 10, 10, 10, 10, 10, 15, 5, 5, 5. So that's your 80 points. Okay. So. Pretty self-explanatory, guys. If you guys have been working through the homework and all that stuff, it shouldn't be any different than what we've been doing. Okay, so, go ahead.
The homework is next Monday?
Right, assignment 10 is next Monday. Okay, so, for that stuff. But again, it might be helpful if you guys work it before. So, go ahead.
Note card?
Yeah, you guys get the 3x5 note card. 3x5, 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 3x5. If anybody needs me to help you show how to work a ruler, I can show you guys how to do that. Some of you guys last time didn't understand the definition of 3x5, so once again, 3x5, 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 3x5. I've said it now a dozen times.
And
so.
I really
What's
need
that?
animate.
Yes, you may use the, in fact, let me write it on the board so that way I can be explicit about what's going to be on there. Okay, so you guys may use one 3x5 note card.
What about 4x6?
You guys can use the rules of the sets, and you guys can use the Boolean laws sheet as well. Michelle, go ahead. I saw her in first.
No,
I'm
no,
sorry.
no, she's just here.
Actually, I have a question about a problem on the beginning.
Okay, yeah.
It's number 3, I was kind of struggling.
Okay, let me go ahead and work it. John, did you have
No.
something? Okay. So, do you want to read it all through, Michelle? I can.
Sure, it's in parentheses, B complement union, and then in parentheses, B complement minus A, and it's the complement of
And that.
yes.
Okay, and that was equal to something? Or?
Oh, B. Sorry.
Okay. This one might be one that doesn't work out, but let's see what happens with this. So, If you were to try to work this, B complement union, using your set difference law, like that, or, I'm sorry, intersect, and that's equal to B. What's really cool about this one that you might not have seen is that you can actually use the absorption law because you have two of the exact same sets there, okay? So I think what you can do is you can absorb that into just B complement using the absorption.
Wouldn't the B complement actually be though, because it's the complement of those ones?
Right. So this would actually be the B, so it actually becomes B complement, complement, like that.
Yeah.
So that's by your absorption law, and that's equal to B. So I use the set difference, and then you just use your absorption here to get to the B complement. Because if you see, give me one sec, Greg. I think it's, you have A union, A intersect B, that's equal to A, right? So right here, the A is actually going to be B complement for that. And you can just simplify into B complement.
It doesn't look quite right to me. So on the left side you have the B complement here. You're using a set difference.
From here to here.
So what's in the parentheses over there, if you rewrite that with the complement on the outside, it'd be B complement minus A and then complement outside the parentheses.
So
So you just
like
rewrite
this
that
guy
in
right here?
parentheses. Yeah.
Okay, so if you were to rewrite that, that would be B union A quantity complement by De Morgan's law.
But the B inside is already complemented.
Right.
To start out with.
Right. Yeah, De Morgan's doesn't do anything. The set difference only affects the A, okay? And then the De Morgan's law would factor out both of these complements. But you don't right here. But you don't have to do that if you don't want to. So, I mean, if you wanted to, you could go ahead and do this and then use De Morgan's law on the big one, but it doesn't really matter. I just saw absorption on that one. It's much more efficient than having to worry about that. Okay, so does that help, Michelle? Or are you still having trouble seeing the,
I'm just confused by what you read on the board.
oh, hold on. Let me get rid of this. Because I think that might be, okay. And this guy, this is just the, right here,
That's absorption.
this is the standard absorption law right there. Okay, so that's what's on the sheet.
Right, and
Okay.
that's double complement.
Right, so this was the double complement go from here to here. Okay, does that make sense? Okay, good. Okay. Any other questions I can answer, or, go ahead, Christian.
I have a problem with another one of
Okay.
them.
Okay.
It's,
Hold on one sec, because I'm sure it'll be longer. Go ahead.
A minus parentheses, A intersect B equals A minus B.
Oh, okay. So what you're going to do is change this into A intersect B complement, okay? Which is the same as A intersect A complement union B complement by De Morgan's. And then from here, because the symbols are opposites and you have three different items there, you'd have to use the distributive law. So this becomes A intersect A complement, union A intersect B complement. So that's okay? This just becomes the null set. Okay, I think that's the negation law. Okay, I don't know the laws off the top of my head, but I know they work. And then if you have a choice between null or set, that just becomes set. So that's going to be A intersect B complement. And then from here, you can clearly see that this is the definition of set difference. Okay. So did you get stuck from here to here? You just kind of didn't see that that could be changed into the distributive. Okay. Yeah, usually, and I keep telling this to you guys, when you start seeing quantifiers that are flipped, that's a dead giveaway that usually you're either going to use absorption or distributive law. If they're the same, then you can go ahead and use the commutative law. Okay?
You don't have to write out the steps you're using?
You do, I just don't have them memorized, quite honestly. I can think about them, but I just don't have them memorized. But I'm sure you guys can go home and figure out what steps they are once you have that. All right, other questions that I can answer for anybody about everything? Everybody knows what to expect. Any questions about that stuff? Okay, so I'll try to get here a little bit early next time, so if you guys do have some last minute questions, I can answer them for you guys. All right, make sure you guys study the first part. Okay, don't underestimate or overestimate your abilities, please. And I will see you all next time. Thank you, sir.